All right, so let's look at graphing those pieces using, oh, sorry, graphing the conics using the polar equations. So what I was doing was using this formula, which is the polar equation for an ellipse that has the pieces kind of picked out of it on top there. However, we can just use these formulas. So let's just focus on these and notice a few things here. Number one is that K is actually giving you the equation for the directrix. So if it's negative, then the directrix is going to be negative K, whatever that K is. And if it's positive in the denominator, a plus sign, then it's going to be on the positive. Remember, cosines are going to be x-axis, and sine are going to be focused on the y-axis. Also, keep in mind that the focus is at the origin in all these equations, and that will help things out. And then remember that if E is equal to 0, you're looking at a circle. If E is, oops, if E is between 0 and 1, you're looking at an ellipse. If E is equal to 1, you're looking at a parabola. So all these pictures are actually parabolas. And also if E is greater than 1, you're looking at a hyperbola. One other thing to remember is that E itself is equal to the ratio of a point to the focus divided by the ratio of the point to the directrix. So the focus is on top and the directrix, hey look, it's written right there, is on the bottom. So focus has an O for on top. So anyway, so let's look back at the one that we were doing. And we can easily find all the pieces. So let's look there at number 80. So we were looking at r equals 12 over 3 plus sine theta. So the first thing we want to do is put this in standard form. In other words, we need a 1 there in the denominator. So I'm going to multiply top and bottom by 1/3. And that's going to tell me that we have 4 over 1 plus 1/3 sine theta. Okay, so that tells me that E is a third. Because that's less than 1, we know that we're looking at an ellipse. We also know that the major axis is going to be on the horizontal, or sorry, the vertical. In other words, the y-axis. We also know we can find the directrix pretty easy. So the blah, blah, blah. So EK is what's on top there. That's the 4. We know that E is a third. So that tells me that K must be 12. So, and now again, because it's centered on the y-axis, this is actually going to be y equals 12. So let's come over here. We're going to count up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the directrix. It's at y equals 12. Okay, now this also can help us out for finding the vertices, because we know, if we know E and we know, well, let's not do that part yet. Let's just think about those vertices real quick. So we know that this ellipse is going to be centered like this somehow. So it's going to have a vertex. Well, its vertices are going to be here on the y-axis. So let's find those vertices. Now remember, this is polar coordinates. So if I'm on the y-axis, what I want to do is look up and look down. So let's see what happens if I look up. In other words, if theta is pi over 2. Well, then r is equal to 12 over 3 plus the sine of pi over 2. which would be 1, so 12/4, and that is 3. So that tells me that I have the point 3 pi over 2. So if I look up, I go to 3. Okay. Now let's look down. So if you look down, theta is 3 pi over 2. So my r is going to be 12 over 3 plus the sine of 3 pi over 2. Sine of 3 pi over 2 is -1, which puts us at 6. So look down and walk 6. 1, 2, 3, 4, 5, 6. And that puts my second vertex right there. And so now we know that the focus is at the origin, 0, 0. We also just figured out that this point was 3 pi over 2, and that this point down here is 6, 3 pi over 2. So these are the y-intercepts, by the way. Okay, so you can think of those as the y-intercepts, looking up and looking down. Now, just again to point out, E is always the ratio of a point to the focus over a point to the directrix. So if you look here, let's pick that top point. He's at 3, the directrix is at 12. So from that point to the directrix, it's 9. And then we claim that the foci, or focus, whatever, is at 0, 0. So the distance to that is 3. And notice that's 1/3, which is E. So if you didn't know where the focus was, you could use this formula to find that. If you could use it to actually figure out where the vertex is if you want to. But notice it works even for that bottom point. So just for the heck of it, look at that bottom point. And how far is that bottom point from the focus? 6, because he's 6 down. How far is he from the 12? Well, 6 to the axis and another 12 makes 18. And hey, look, that's 1/3. So pretty cool there. But let's go ahead and find those x-intercepts as well. So the x-intercepts are going to come from looking left and right. Now, these are not the vertices. The vertices are only on the major axis. But for the x-intercepts, let's look right. If we do that, then theta is 0, right? In which case, we just get a 4. So if I look right, I'm going to go 4. 1, 2, 3, 4. And let's look left. This is symmetric, recall. So if I look left, which would be at pi, sine is also 0, so we get a 4 again. So 1, 2, 3, 4 when I'm looking left. And so now we have our picture. We can just make a nice, perfect nice perfect ellipse there. So notice though we were easily able to find the eccentricity, the shape, where the major axis was, the directrix. We were also able to find the x-intercepts, the focus, and the y-intercepts I didn't actually write down, but the y-intercepts were 0, or sorry, 4, 0, and pi, blah, 4 pi. So we are able to find the intercepts, the focus, the eccentricity, the shape, the axis, all that stuff relatively easily. So let's actually do one more example. Let's see, let's look at, how about 79? It's got a minus in it. So let's look at number 79, 6 over 1 minus 2 cosine. All right, so, oops. So 6 over 1 minus 2 cosine theta. So the first thing we want to do is put it in standard form, but it's already in standard form. So actually I can pull the E right out of here. The E is 2. It's not -2. That negative is the one telling us where the directrix is and kind of where the focus is. Not that focus, but anyway. So also, well, because this is greater than 1, we know this is a hyperbola. We also know that the major axis is going to be the horizontal, or the x-axis. And we also, the negative is going to tell us that the directrix will be on the negative x-axis. So let's actually find the directrix real quick. So E times K is actually the numerator, which is 6. And we know that E is 2. So that means K must be 3, which means the equation is x equals -3. That's the equation for the directrix. So 1, 2, 3. So x equals -3. Again, the negative comes from it being a minus in the equation, and then the 3 just comes from looking at the top. So we've got this. Now we also, remember, we know that the focus is at the origin. But we could also find that ourselves after we find some vertices. So let's go ahead and find the vertices. So again, here the actual vertices are going to be the in this case, the x-intercepts. Oops, because he's the major axis, right? So on the x, we want to look right. So there's looking right, and here's looking left. So let's see what happens if I look right and look left. So 6 over 1 minus 2 cosine 0. Cosine of 0 is 1. So that's a -6. And if we look left, cosine of pi is -1. So that ends up being a plus there. And 6/3 is 2, right? So let's go ahead and graph those points. So if I look to the right, I actually move back 6, you guys. So let's get that on there. Hold on. So 1, 2, 3, 4, 5, 6. So if I look right, I walk backwards 6. If I look left, I walk forwards 2. So there they are. Notice, even if we didn't know what the focus was, let me just show you, we can figure that out, because E is the ratio of a point to the focus over a point to the directrix. So if we know that E is 2, and we know, just pick a point, it doesn't matter which one. Okay, I want to pick that one. So he is 1, 2, 3. He's 3 away from the directrix. So that means that to the focus, he's going to be 6. So notice that he is 1, 2, 3, 4, 5, 6 away. So the same thing would have happened if you'd used the other point, but see, I can figure out where the focus is because I know he's 6 away from that vertex. So we just found the x-intercepts. They are -6, 0, and 2 pi. So now we could go ahead and look up and down and find those y-intercepts. So the y-intercepts in this case are going to be looking up and down. So if we look up, we're looking at pi over 2. Cosine of pi over 2 is 0, so r is going to be 6. And if we look down, theta is 3 pi over 2, in which case cosine is 0 again, and we get that r is 6. And I mean, it's symmetric. So let's go ahead and put in 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That was looking up, walking 6, looking down, walking 6. So now I can put this together and graph a beautiful picture. And then again, it matches up nicely. So looks good. Here it is. And we have another polar graph. So again, definitely not as difficult as I was making it seem, trying to use that other formula, which wouldn't have worked with a hyperbola anyway. But so we found the eccentricity, we found the shape, the major axis, and then we were able to find the directrix, and the x and y intercepts, and then the focus, of course, was just there at 0. So there's all of our pieces. Oops. I'm trying to leave, I swear. Stop sharing.